Hi everyone, welcome to the sixth session of our software manual testing series. In this session, we are going to cover some more important questions that are frequently asked in interviews. Let's start. Here is the first question of part 6 series. What is test bed in manual testing? A test bed is simply the environment where testing takes place. It includes all the hardware, software, configurations, and test data needed to execute your test cases properly. For example, if you're testing an e-commerce website, your testbed might include Windows 11 operating system, Chrome browser, version 128 MySQL database Tomcat server, and test data like user accounts, products, and payment details. Together, these make up your testbed, the setup used to run tests and observe results. Now, here is the next question. When should you opt manual over automation testing? Manual testing is the better choice in these situations. When you're working on short-term projects where setting up automation would take more time than the actual testing. When doing ad hoc testing, which is unplanned and depends on the tester's intuition and creativity. When performing exploratory testing, where testers freely explore the application to find hidden issues, and when performing usability testing, because only a human can judge how user friendly and intuitive an application feels. In short, manual testing is ideal when human observation, creativity, and quick feedback are more important than repetitive execution speed. Move on to the next question. What makes a good test engineer? A great tester isn't just someone who runs test cases, they have a special mindset and skill set. First, they have a test to break attitude. They don't just try to see if the software works, they try to make it fail and uncover hidden defects. Next, they have a strong desire for quality. They always aim to deliver a stable, user friendly, and bug free product. They also possess tact and diplomacy because communicating bugs to developers and teams requires respect and clarity. Strong communication skills are essential to write clear test cases, explain issues, and report results effectively. And finally, a good tester has the ability to judge situations, to decide what to test first, when to escalate an issue, and how to handle critical situations under pressure. Now, let's see the next question. What is the difference between static and dynamic testing? Static testing means testing without executing the code. It focuses on reviewing documents, design, and source code to find early defects, like syntax mistakes or incomplete requirements. Examples include code reviews, walkthroughs, and inspections. On the other hand, dynamic testing involves executing the actual software. Here, we check how the system behaves when it runs, verifying its functionality, performance, and reliability. Examples include unit testing, integration testing, system testing, and acceptance testing. In short, static testing equals prevention of defects before code runs. Dynamic testing equals detection of defects when code runs. Both are essential for ensuring high quality software. Now, the next question. What is the difference between system integration testing and user acceptance testing? System integration testing, or SIT, is all about checking how different modules or systems interact with each other. Here, testers verify data flow, communication between APIs, and integration points to ensure the system works as a complete unit. On the other hand, user acceptance testing, or UAT, is the final testing phase before release. In this stage, end users or business stakeholders test the application to confirm it meets all business requirements and is ready for real world use. In simple terms, SIT checks technical integration and system flow. UAT checks business functionality and user satisfaction. Both are equally important. One ensures the system works well technically, while the other ensures it's valuable and usable for the end user. Now move on to the next question. What is the difference between smoke and sanity testing? Smoke testing is done on initial builds of the software. Its main goal is to check whether the build is stable enough to proceed with further testing. It follows a shallow and wide approach, verifying all major functionalities. Smoke tests are usually documented and scripted, and can be performed by developers or testers. On the other hand, sanity testing is done after the build passes smoke and regression detection tests. It focuses on verifying specific functionalities or bug fixes to ensure everything works as expected. It follows a narrow and deep approach, concentrating on particular areas of change. Sanity tests are usually not documented and are performed mainly by testers. In short, smoke testing checks build stability. Sanity testing checks logical correctness after fixes. Both are quick checks, but they serve different purposes in the testing cycle. Now, move on to the next question. What is entry criteria and exit criteria? Definition. Entry criteria are the conditions that must be fulfilled before starting a particular testing phase. Exit criteria are the conditions that must be fulfilled before ending that phase. Purpose. Entry criteria ensure readiness to begin testing, confirming that all required resources, environments, and documents are in place. Exit criteria confirm that the testing has been successfully completed and objectives are met. Focus. Entry criteria focus on prerequisites for starting testing, while exit criteria focus on ensuring completion and quality before moving forward. Examples. Entry criteria might include having test cases prepared, the system ready, and test environment set up. Exit criteria could include that all planned test cases have passed, no critical defects remain, and sufficient coverage has been achieved. Responsibility. Entry criteria are generally defined by project managers, test leads, and developers. Exit criteria are validated by testers, stakeholders, and often require a sign off from the product or business team. So, in simple terms, entry criteria equals are we ready to start testing? Exit criteria equals have we tested enough to stop and move forward? Here, all we are explaining in table format because it is easier to learn and maintain as notes. Now, here is the next question. Explain integration testing. Integration testing is performed after unit testing, where we test how different modules or components of an application work together. For example, after testing the login, search, and payment modules individually, we check if they integrate correctly, like whether a user can log in, search a product, add it to the cart, and make a payment without any issues. The main goal of integration testing is to find defects in the interaction between modules in type, such as data mismatches, incorrect function calls, or communication failures. There are different approaches to perform integration testing. Top-down approach, where testing starts from the top module and goes downward using stubs. Bottom-up approach, where testing starts from the lower modules and goes upward using drivers. Big bang approach, where all modules are tested together in one go. And the hybrid approach, which combines both top-down and bottom-up methods. So in short, integration testing ensures that all modules work perfectly when combined together, giving a smooth end-to-end experience to the user. Now, move on to next question. Give difference between top-down approach and bottom-up approach. In the top-down approach, testing starts from the topmost or main module and moves downward. Here, higher level modules are tested first and then lower level ones are integrated step by step. Since the lower modules may not be ready initially, we use stubs, temporary programs that simulate their behavior. For example, if we are testing an order management system, we'll start by testing the main order module first and then integrate the payment and database modules later. In contrast, in the bottom-up approach, testing starts from the lowest level modules and moves upward. Here we use drivers to simulate the higher level modules that are not yet developed. This approach helps in testing lower level components early, like database or API modules, before integrating them into the main system. Both approaches are useful depending on the project type and development progress. Now, move on to next question. What is pesticide paradox in software testing? How to overcome this? The pesticide paradox means that if you keep running the same set of test cases again and again, after a certain point, they stop finding new bugs. It's just like how pests become resistant to the same pesticide after repeated use. For example, imagine you're testing a login feature with the same username and password every time. Initially, you may find a few bugs, but after running those same tests repeatedly, you might stop finding new issues, even though there are still hidden bugs elsewhere. So, how can we overcome this? By reviewing and updating test cases regularly, adding new scenarios and edge cases, using exploratory testing, and keeping test data and environments fresh. This ensures that your testing remains effective and continues to uncover new defects. In short, don't let your test cases go stale. Keep improving them to make your testing smarter and more powerful. Now, move on to next question. What is the difference between manual and automation testing? Manual testing is the process where testers execute test cases manually without using any automation tools. It's time consuming and prone to human errors, but it allows for human observation, which helps find usability and design issues. It's best suited for exploratory, usability, and ad hoc testing. On the other hand, automation testing uses tools and scripts to run test cases automatically. It is much faster, more accurate, and reliable, especially for regression, load, and performance testing. However, it doesn't provide the human touch, meaning it can miss user experience related bugs. In terms of cost, manual testing has a low initial investment but gives low ROI over time. Automation testing requires a higher investment initially but provides better ROI for long term and repetitive testing cycles. In summary, manual testing is slow but insightful. Automation testing is fast and efficient. Both are essential and complement each other in the software testing lifecycle. All right, that brings us to the end of part 6 series. In the next part, we'll continue with more interesting and important topics that will strengthen your testing understanding further. Please comment below if you have any questions or need any clarifications. For mock interviews or online classes, you can contact us at the email ID provided. Send us an email with your contact details and we will get in touch with you. Don't forget to follow and subscribe to Tech Margadarshi for upcoming videos. Thank you and happy learning.